Hey y'all, this is kind of cool. I'm actually coming to you from inside the mobile quarantine facility that the Apollo 11 astronauts had to stay in after they came back from the moon, just to make sure that they didn't bring any diseases with them. I think they need to replace that light bulb. What do you think? On with your show.
Hey guys, and welcome to the show. I have Ryan Berry with me.
Hey Lex, how's it going today?
Hey Ryan, how's it going, man?
It's going well. Thanks for having me back on. Always nice to see a friendly face.
Yeah, man. Listen, I love having you as a guest. You know that. And today we're going to do some cool stuff, right? We're going to do containerization. We're going to take an app. We're going to create a container.
Exactly. Yeah. You hear this word containerization. Everybody's talking about it. Kubernetes. So all the hype, all the rage. Take a little bit of a walk down a path to understand the why, and then we'll walk through a lot of the how. A lot of times, I have customers that look at these config files and YAML files and are like, oh my God, this is really complicated. And it's really not when you start kind of piecing it apart. And hopefully we'll be able to do that today.
Yeah. My understanding is that it's really just a small virtual machine.
That's one way to look at it. It's a lot lighter weight than a virtual machine, because a container doesn't have to have a complete copy of the kernel that's actually running to be able to interact with hardware and the network interfaces and that sort of thing. So a container sits on top of some host operating system, and that host operating system actually could be a VM itself. So you could have a VM running Docker or Kubernetes that actually in turn runs a number of containers. And one of the significant benefits over a container in a virtual machine is that if you have a host with some prescribed amount of hardware, every one of those virtual machines that you spin up has a duplicative copy of the kernel and all the other components needed to interface and expose hardware to the operating system. And there's overhead with that. And if you have, let's say you have a web application and you've got 5 web servers, maybe all 5 of those web servers are running as virtual machines on a host. So let's say that you've got a host with 20 cores, just make it easy number, and you got each one of those web servers has 4 cores dedicated to it. You've exhausted the capacity of that host, and more importantly, maybe you have other compute needs. Maybe you have like a small application that you want to light up, and if those web servers are dedicated to running a task, you don't have a place to put that. You need another host or another environment. Containers allow you to take make effective use of that hardware that you have, and being able to put hundreds, or maybe I should just say many, I guess, for lack of a better descriptive word, applications on an environment, and really increase the density of applications to the hardware that they're running on, to be able to make effective use of that hardware. So if you have a period of time, maybe when that website is not getting a lot of traffic, it might make sense to have resources available to be able to handle and do other things, and containers can help in facilitating that.
Cool. All right, let's see what you got.
All right, yeah, let's go ahead and take a look here. I will share the screen, and this is actually a picture outlining exactly what I just described, and I'll just kind of show it, kind of reiterate my point is that when you have virtual machines, so you have the entire stack of stuff, including the operating system, the kernel, and any binaries and so forth that are required for your application, running in its own little isolated island. And then you have the host has hypervisor running on top of that, and that's sitting on top of the host operating system, and finally get down to that purple box where the hardware is. When you look at a container, you can you have a Docker engine or some sort of container runtime environment. We'll talk a little bit about that. I have Docker running on my machine, and and we'll kind of compare and contrast that to something that we have in Azure called Kubernetes. But Kubernetes is really just running Docker containers. It facilitates moving them around to different nodes and responding to load. But at the end of the day, what you have or what it's running is a Docker container, and you can run those locally on your machine. So you have to have some sort of runtime that's able to interpret that container and light it up, and then sitting within that Docker runtime are some binaries and so forth. If it's a Linux, if it's Docker running in Linux mode, it's going to have some facilities to be able to support Linux containers, and then you can deploy any number of applications on top of that. So it's a way to virtualize the application. Maybe is one way to thinking of it, as opposed to the actual operating system, which would be something you do in the VM world.
Okay. And we have this subsystem, right? The container subsystem built into Azure as well.
Correct. Yep. So in Azure, the primary hosting platform, we have a couple different places that you can run containers. There's two really simple places you can run containers. And one is we call application services, which I like to. It's kind of akin to like IaaS as a service or Tomcat as a service, Apache as a service, a web hosting facility. And one of its newer features is the ability, instead of to post all of the assets needed to make an application function to a server, you can point at the app service environment to a container, a registry, whether it be Docker Hub or your own private repository. Say, go run this container. So if you have a app service plan with 5 nodes, your container is going to be running on all 5 nodes. So that's actually a really easy way we have in Azure to run a container. Second way we have in Azure to run a container is something called Azure Container Instances. And this actually they spin up rapidly. So basically what you can do is say, Azure, I have this container, I want to run it right now. And it will create a public IP address for it. In a matter of a couple of seconds, you have an endpoint that you can actually use to access your application. Where I have customers using that is for doing things like build verification testing. So maybe they have automated tests or automated build environments that actually build and deploy their application. And before they deploy it into an environment, they want to make sure the thing didn't break. So an easy way to do that is to deploy it. And if you have your application in a container, you need some receptacle to push it into. So a really easy way to do that is to deploy it into these Azure Container Instances. You can run some tests against your application and say, yep, your application works fine. And then one benefit that the customers have from a billing standpoint is Azure Container Instances. We charge the customers by the second. So just if it's up for 30, 40 seconds to test and do some smoke or build verification tests in the app, we can do that really quickly. Shut it down, and they're really cheap to run for those really shorter duration type operations. The third facility we have is a full-fledged environment called Kubernetes that I'm sure many individuals out there have heard of, and basically it's a step above this engine I show in the slide, where it's an orchestrator where you have a pool of compute resources, and you basically say, I want a fraction of this CPU to be dedicated to this application, and when the CPU hits a certain load, I want it to create another instance of my container on some node that has capacity. So basically, Kubernetes is responsible for balancing things out, making sure your hardware is effectively utilized, responding to, and directing traffic, because now you have maybe 10 copies of your web application running across a number of nodes. So there's handles all the load balancing for it. So it's a fully fledged managed environment that would typically be used for production applications. So kind of multiple different ways that you can host your application in a container in Azure.
All right, cool. Let's build one.
Yeah, okay, let's walk through how that works. What I'm going to do, I have, let me pull up, get things all situated here.
All right, so what are you running here?
All right, so I've got Visual Studio Code, and let me make this a little bigger. So this is actually I'm kind of starting way back with a let's say that you have a container that you want to use as maybe open source that you want to deploy somewhere.
Okay.
And so I'm starting with that angle, and then we'll walk through how you can construct one yourself.
Okay.
So this is an application, and what I'm going to do is kind of walk through the steps it takes to actually okay, so I'm just getting things squared away here. So when let's say that you have a container that you want to use that's from some public place, and I have an example of that here. I'm going to go ahead and go back to the command that you would use. So okay, so this is actually a repository that is publicly available on Docker Hub. Somebody has a really simple .NET Core application. So the way this works, if I want to deploy this into some place like Kubernetes, so I'm going to start with the simple approach of running it locally on my machine, and then we'll deploy it into Azure. So the first thing you have to do is obtain a copy of that image, which is all the artifacts needed to make this application function. So the way you do that is by running this command called docker pull. And what that does is it vacuums up the bits needed to be able to make this image function. So if I run this, it runs very quickly because I already have a copy of it on my machine. And basically what it did is it compared my version to the version that's out on Docker Hub and said, yep, you have the latest version. I don't need to do any work. So now I have this thing locally. So if I run that command that I just ran a second ago, these are all of the images that I have locally on my machine. And you see I've got a couple deployed here that have different tags, which means I have different versions. I have a development version of this one. I have the latest version. Some of these have very specific versions. These are things that I've actually pulled down from the Microsoft Container Registry, which we'll see when we actually build a container that all a container is a layer of a whole bunch of other stuff. So you might want to start, if it's a .NET Core application, you need to start with a image that has .NET Core runtime bits on it, and then you kind of layer on everything else you need. So that's what these other things are. But down here is the image that I just pulled. So now that I have it on my machine, I need to get it to a place where I can actually expose or point Azure Kubernetes services and AKS to actually run it. And I'm going to go ahead and flip over here to my container registry. So I've called it ryberry. Is the name of my registry. So the endpoint is, let me make this a little bigger here, is ryberry.azurecr.io. So that's the endpoint that my container registry is on. Okay. So what I can do now that I have this image here locally is I need to actually tag it to say, okay, I have it local, but I want to also push this image to a container registry that I have permission to access. So the way I do that is I say docker tag, and I give it the name of the image that I want to tag, and then I'm going to go ahead and copy this just for laziness, and I give it the location that I want to put it, and then I give it the name that I want to name this image up in my container registry. So basically, I'm taking a local image, and I'm saying I also want it to be deployed to this other endpoint. It's not actually going to upload it. It's just going to say this is a possible location that I can actually push this particular image if when the time comes. So that's a simple command so now I basically, so this particular image now has two destinations, local on my machine, and it can also be pushed up into Azure. Okay. So now I need to get this thing into Azure. And the way you do that is by using this other command called docker push. And what this is actually doing, and it happens very quickly because it's already there. It's uploaded into Azure. And the way that I can actually see that, if I go into my container registry, and I go into repositories, I should be able to see Hello Core, and I can see there's only one version, the latest version, so I can actually see that it was uploaded earlier this morning. So it's already, that's why it uploaded really quickly, because the version that's up here now doesn't differ from the one I already have. So now it's sitting in the Azure Container Registry. Azure Container Registry is private, so the only way you can't access this endpoint without some keys. So I already Docker on my machine is set up to be able to authenticate to my repository, which is why those commands succeeded. So I had to, when you set up Docker, you configure it to be able to talk to different registries. So when I installed the Azure tools on my machine, I've told it that this is a registry I want to interact with. So that's how come all those commands work. But like if you were to try to run that, you wouldn't be able to access this because you don't have my keys.
I gotcha.
All right, so now it's sitting out in my container registry, but it's not doing anything.
Right.
So this is where you actually need to instruct things. So what we're going to run it in kind of the more complicated environment in Azure Kubernetes services, which is that orchestration environment. And I'm going to show you where it actually runs. If I go back to my portal and go to AKS, this is my Kubernetes cluster. And in here, I have one node pool. Node pool is a construct. When you set up a Kubernetes cluster, you have to have a runtime flavor established, whether it's going to run Windows containers, it needs to have a Windows host OS, or if it's going to run Linux containers. Kubernetes has this concept called node pools that allows you to actually have a pool within the same cluster. You can have a pool of compute nodes that which are just VMs that run Windows containers, and maybe one that runs Linux containers. So I only have one pool of nodes in my environment, and you can see that it's running Linux containers, and it has two VMs in it, and they're DS2 V2 VMs. And I want to show just a really interesting thing about that when I actually go to virtual machines,
yeah,
they don't show up here. So they're actually kind of hidden a little bit. If I go to resource groups, there's this really oddly named resource group. It's MC and then AKS test. This is actually the resource group that my cluster was in. I kind of glossed over that. And here's the name of my cluster, and this is the region it's in. So it actually, Azure created this for me. And when I go into it, I can see there's a bunch of public IP addresses. I actually have stuff deployed and running in my Kubernetes cluster right now. There's a load balancer as well as a security group, but then there's a VM scale set. If I go inside of here and go to instances, there are two, okay. and I can see that they are DS2 V2. So this is actually where where Azure deposits the compute that's required to be able to make the environment that my application gets deployed to. You see it's got some special tags that are applied to it, and I'm sure this is actually under the covers for AKS to be able to find and identify where that environment is. So these are some internally created tags when I actually deploy this, but just kind of want to make it clear where your stuff actually goes when you actually deploy it.
Yeah.
All right. So to be able to deploy something into Kubernetes, there's two ways to do it, and I'm going to show you a really easy way first, and then we'll walk through this file. So an easy way to do it, I'm going to go. I have a command in here. Okay, so this is actually I'm using the command line tools for Azure AZ, and there's a special command. So when you actually backing up a little bit further, when you install Kubernetes yourself, there's a dashboard that you can access through the master nodes that in the Azure world that we actually abstract away from you, because there's some nodes that all the traffic actually goes through to be able to get to your application environment. So you notice I only have 2 compute nodes, but there's some other stuff, infrastructure that runs in front of that we take care of for customers, which is one of the big benefits of using AKS versus building a whole bunch of VMs and doing this yourself. So I'm using this command line tool, the Azure command line tool, and there's a cool feature of it called Browse. So basically, this is AZ AKS is how I'm now managing AKS, part of my Azure subscription. And Browse actually establishes a tunnel from my machine to a container running in my cluster that actually has the management environment of Azure running in it. So this is the resource group that my container or my cluster is in, and that's the name of my cluster, as we saw a little bit ago. So when I run this, what it will do is it will establish a tunnel, and it takes a second. This is a Kubernetes dashboard. So this is actually, now we're stepping outside of Azure into just the open source, cloud native, environment that, this would actually be what you would see if you deployed your own Kubernetes cluster in your own environment. And the reason I had to create that tunnel is obviously, I don't want nefarious people to go out here and make deployments and delete things in my Kubernetes cluster. So because Azure is already, the AZ command line tool is already authenticated to my Azure subscription. That's what allowed me to allow that command to function. So I do want to highlight here that Kubernetes actually has this concept called namespaces, which allows you to create partitions of your AKS environment. So you could effectively actually have a development environment and a production environment on the same cluster of machines. And I could grant you the ability to deploy to the development namespace, but not to the production namespace. So it's a way to kind of refine and narrow down all of those containers that are running in my cluster. So there is a namespace called default. This is, and I'll show you. This is where stuff goes by default if you don't specify a namespace. So this is all of the user deployed containers run. But there's a bunch of stuff that Kubernetes deploys into. Let's see here. Why did that not? Let me go back to pods here. I thought there was an easy way to see this. Let me go. It's not. I thought you could actually see the stuff. I was making a liar out of me. So I have to point to that. What I was trying to get at is that there's stuff running in. Oh, there it is, right here. I'm sorry. I'm in the. I got lost for a second. There. So this is all. So I just switched namespaces to the internal. These are system namespaces. So what happens when you deploy Kubernetes? There's a bunch of containers that get deployed to Kubernetes to make Kubernetes work. So like I can, if I go to public, nope, that one doesn't have anything. It's a monitoring. Where is the
core DNS is just like DNS services?
Yeah, exactly. I thought that actually under kube system that I would actually see OMS agent, core DNS metric server. So there actually is a container that's hosting that website. I was just trying to find it. So
yeah,
or this website that I'm actually on. So that's where all the internal stuff is running. So for sake of time, instead of poking through here, and I'll just kind of gloss over that. But default is actually where all of the containers are deployed that I've already lit up in my application. So a really easy way to deploy something rapidly in Kubernetes, I can actually go to create. Actually, I want to go to deployments. And I want to create, I could say create an app. And I'm going to go back to my command line here and just copy. This is the name of the container, my container registry / the name of the container. So I'm actually going to tell it that that's the image that I want to run. That's one of the parameters. So I'm going to say new core, and I'll just give it a different name. And I'm going to say that I want to make it externally accessible, and I want to take port 80 from the external IP address that's going to be assigned to this, and give it to port 80 in my container. So just a really simple deployment.
And to be clear, those ports don't have to match. Right,
exactly. Yep. Yeah, and because do you see I've got some other options making this internally owned. So I could actually deploy a container that is only accessible within Kubernetes itself. But I'm going to just for the sake of showing something interesting and make it external.
Yeah. So my guess is that a lot of those system level Kerberos containers are probably marked internal only.
Yeah. So it's doing a deployment. So this is actually the application already running, and you can see it actually has the same. So I'm deploying the same application again, just with a different name, and it will also get a different IP address because I told it I want it to be externally accessible. So if I go to services and wait a minute, so I can see this is the internal IP address of that service, and if I hit refresh a couple times, it does take. At some point, the external endpoints column. What's happening under the covers is Kubernetes is pulling down this container image. It's already deployed it because I can see it's got an IP address, and I can see the ephemeral ports that it's listening on port 30,711 in the container and exposing that to port 80. And under the covers, Kubernetes it actually has some hooks to be able to talk to infrastructure that it's running on. And in Azure's case, there's some stuff that we've contributed to as part of the Kubernetes open source project that actually knows how to talk to Azure, specifically to be able to do things like create public IP addresses. So that's actually what it's doing under the covers. It's at some point here, it will obtain there we go. So it's got a public IP address. Yep. And if I open that up, it will load. And it's kind of doing a cold start. First time I've hit this thing.
Okay.
And while that's loading, I'm going to load up my other one that I already deployed just to show you that it's uh-oh. This is what I should get. Hello, .NET Core. And come on. What's going on here?
Hit refresh.
Yep, that's what I just did. It's refreshing again.
It may not be all the way up.
Yeah. But we should actually see what I'm showing here. So there might be something amiss going on, but that's how you can deploy a container in a really simple way without having to create any YAML files and doing anything complicated. In fact, I can actually go back to this now to the new one I just deployed, and if I go to edit, I actually can get. This is actually kind of reverse engineering now. There's a lot of extra stuff in here that you'll see when I show you my my application or my file that you can actually use as a starting point to kind of build your own deployment. So a lot of customers in a production environment, let's see, create. Oh, so there was an issue when I actually created the endpoint. So that's I should have looked at the error message here. So I already have one running with that name.
Yeah. So, on the same endpoint.
Yeah. So anyway, that was why that failed. Kind of took a chance and just thought it would. But
no worries. We'll pretend this is like a baking show.
Exactly.
On TV.
Yep, there
Look,
you go.
we put it in the oven and voila, it's done.
Yeah, exactly. So so this is actually how you can easily deploy one without creating any stuff. So I'm going to go ahead and just kill this. So that means that my connection to the portal is broken now. Okay. So let's go ahead and take a look at how you actually create instructions or kind of a deployment manifest to tell Kubernetes how to deploy this application. Okay. And this is kind of a very simple, the simplest environment or simplest deployment file that you could construct. So basically, what this is, I'm telling it I only want replicas is how many pods. The way this works is that think of a pod as a running instance of your container. So you can scale pods differently than you can scale VMs. So the VMs or the pods rather use a fractional component of the underlying host's CPU, and I'll show you some more advanced versions of these where you can actually specify how much CPU you want your application to ask Kubernetes to get, and what Kubernetes will do is find a machine with that capacity and put you on there. But in my case, I'm not actually specifying it. I'm just saying I want one copy of my application running somewhere. Just find me a spot. So that's why I said this is the simplest.
So that's kind of neat that it automatically goes and finds you a place.
Exactly. So you ask for a fractional amount of memory and a fractional They call it milli CPU. So a fractional part. So you don't actually ask for a core. You ask for a fractional component.
Cycles on a core.
Yeah.
So it would
That's
just be
one
cycles
way to
on a
think of
core.
it.
Yeah.
Yep.
Yeah.
And so in here, I'm telling it, so you can have a deployment have many containers in it. So I could have a front end and a back end associated with my application. In this case, I just have a simple application. So there's my container we've been working with. And you can see I'm telling it the container port is 80. And this is actually an interesting component that I'm actually specifying. So I think I actually have a command here, secrets. Where is my secrets command? Let's see here. Whoops. Secrets. And I think it's maybe it's describe secrets. Yep, that's it. All right. So my Kubernetes cluster has the ability to house secrets. They're not hardware encrypted secrets, but it's a like Key Vault is, but it is a location where it can keep things that are important for Kubernetes to run. So like in the Azure world, it's running under an identity. So this is actually like a service. This is the secret for the service account, basically, that it's running under.
Yeah.
If I scroll up a little bit more,
you don't care that that's on YouTube now, right?
No, it's okay.
Okay.
This is all just junk for testing.
Okay.
And the other thing that's in here is a secret that I've already set up front that actually tells Kubernetes how to get to various container registries. Remember I said that my container registry is private?
Yeah.
So I created a secret called, actually in Kubernetes when you configure it creates one for you called ACR-auth. And basically what this is it's sitting in a file, this particular Docker configuration JSON file that actually is the credentials to be able to get to my key registry or my container registry rather.
Okay.
So when I create one of these Kubernetes deployment manifests, I need to tell it where to go to get it, and then I need to tell it what secret to use from its internal secret store to use as credentials to go out and retrieve that. So that's what this thing is. And then the last thing I need to describe is I'm putting a load balancer in front of this, which is kind of silly, but because I only have one. So what would normally happen is that you would typically have a scaling rule to tell Kubernetes create more of these if a load hits a certain point, and I'll show you how that works here in a second. So now we have this kind of the simple descriptive file to tell Kubernetes how to deploy my application. So the way that you deploy it is using a different utility called kubectl. And I've heard many different variations of this. There are Linux, kubectl, kubectl. This is the command line utility that you use to administrate a Kubernetes environment. So notice there's a lot of things that are in the command line. I'm running them locally on my machine. Another way that I have actually glossed over a little bit that's actually really cool is you can actually run them directly in the Azure portal. If I click that little icon up here at the top, and I can actually run when this actually loads up, and you can actually pick PowerShell or Bash shells. And actually interesting note, this is actually running in a container. So we're talking about containers. I'm actually showing a container running in Azure that customers use every day.
Oh, wow. That's cool.
So kubectl, these tools are all installed here. So one of the benefits of using this feature in the portal is you don't have to install and configure any of these things. They're already, so this is another place that you can use them.
Okay.
So so now I need to actually tell kubectl that I want to install this into my cluster. And the way you do this is you just say apply, and then I give it, say, -f, and I'm telling it the file name. My file name is simplecontainer.yaml. And when I do this, it's telling it's already deployed, because I showed you a little bit ago. I created a new core, so it said that nothing's changed in here, so it's already running.
Right, but that's the string.
Yep. So let me see. I'm gonna show something else here. I have a command here that I actually had off on the side. So I've told it that I wanted one copy of my pod to run, so that there's one container instance. So what I'm going to do now is I'm going to tell it I want a minimum of 2 and a maximum of 5. And when the CPU percent hits, I'm going to actually lower this down, and I'll show you why in a second. When it hits 50, I want it to start adding more. So this is actually where some of the power of having an orchestrator comes into play. So I'm going to give it some commands, and I'm going to go back to that portal that we showed. Create a tunnel just so we can watch what's happening. All right, so here we go. And if I go to pods, I can see that it says actually it's in a waiting state, because it's actually, I told it to want a second one. Remember when I deployed it, it only had one. That's why it's got the little, it's not green yet, because it's actually deploying another copy of this. So I can actually go to nodes, and I can actually, these are the physical nodes. Now talk about why there's 3, because even though I told it I only wanted 2, there's one that has a virtual node. Azure has the ability to create to scale to physical infrastructure that you don't actually have deployed. That's what this third one is. But I can actually see what's running on these. Like if I go to AK, I can actually see I've got new core and test core. So it looks like it actually deployed both of those test cores. It put them on physically separate nodes. It may or may not do that. It depends on what the state of affairs is within my Kubernetes cluster. But I can actually see physically this. Now I'm looking physically at one node. I can see details of what the disk and memory pressure looks like. How much CPU is allocated, how much memory is allocated. So I can see that there's only one test core running on this node, and then if I go to the other node, I'd be able to see the other. So there's the other one. So that's how it's dispersed them. So what I'm going to do, and because there's a load balancer sitting in front of that, if I open this up, it's actually hitting one of those 2 nodes. I should have made this a little bit more interesting and actually told it, like written out the host name, but it would actually, there's a load balancer, an implicit load balancer sitting in front of this that's directing traffic to this.
Yeah.
So what I'm going to do is I'm going to use this cool utility called the Nettle. It's a .NET application that I'm actually going to load this sucker up with a bunch of requests, and I'm going to give it the endpoint of this application.
Okay.
And I'm going to tell it to run. And if I go back here to pods, let's see if we can actually make this thing. So it says there's 2.
Still 2.
Yeah, there's still 2. Let me try hitting that. So I was getting 2,800 requests per second. Let me try hitting it even more. See if we can actually get it to actually scale and hit our 50% limit. Oh, there we go. It's actually so it created one. I don't know why that failed. That's interesting. Let's see. CPU 70. Let's see. Not sure why I've got. It's doing something. I can see a couple moments ago it was pulling the image again.
Is it trying to use the container that failed to start earlier?
No, that might actually be causing some havoc here. Yeah. Let me see if I can created pod replica. Terminated error. So it is actually, it's trying to do something. I'm not really, I have to troubleshoot instead of trying to do it live. I might have interfered with something when I actually created that other deployment. But
yeah,
it
that's
is.
okay. We get the gist. It'll automatically scale up.
Exactly, it is doing something to actually try to connect up. So or trying to expand.
So your niddle tool just creates an artificial load.
Yeah, exactly, and it's a simple website. That's why I dialed it down to 50% because it's probably it'd take a lot of load to try to actually get this thing to need more capacity. So, but anyway, so that's the beauty of Kubernetes, and it'll move stuff around, scale for you, manage deployments, manage creating infrastructure that are needed, things like load balancers and IP addresses in Azure and so forth. So.
Yeah.
All right, so now let's start. Let's try building one of these from scratch. And this is where we'll go a little bit off-roading.
Okay.
Because I know the application works as a container, and it. I just haven't deployed this. Actually, I'm going to go ahead and reopen this up because I'm going to reuse this simple container. So we'll actually use that file I had open, and we'll actually deploy this into Kubernetes, and hopefully everything will work just fine. So this is a simple .NET application. I'm going to show you a couple. So in Visual Studio, there's a couple ways that you can actually debug a web application. And one is just to use IS Express, the inbuilt version of IS. And I'm just going to kind of walk through this to show you some of the powerful things that exist within Visual Studio to allow developers to build these. So this is now, it's not really anything earth-shatteringly new. When the debugger fires up, you see it's running at port 44339. This is running through IS Express.
Okay.
So when I created this project, I told it there's actually a special type of .NET Core project that actually creates a. I'll use my fancy dancy pointer here that actually created this Docker file for me.
Okay.
I could actually, if I already had an existing project, I could actually just create this Docker file. And Visual Studio knows how to interpret it. And you can see it actually adds a special command here. It says build Docker image.
Yeah.
So you can do it after the fact is the point here. So let's walk through a little bit what this is.
Okay.
So what this is doing is I had to start with a base, some pre-existing container that, whether it's a really stripped down version of Linux, like Alpine Linux that has basically nothing on it, and you have to kind of build on top of that.
So kind of like a container template.
Yeah, exactly. So I have to have a starting point, and this is a .NET Core application. So this is a Linux .NET Core application specifically. So this particular base container is a Linux operating system. I actually don't know what distribution. It's probably Alpine or something under the covers, some flavor of Ubuntu. And I'm telling it that this is the directory that I want to deploy all my stuff into, and that I want to expose port 80 and port 443. From within my container when it's running on a in Docker or Kubernetes or whatever.
Okay.
And then I'm layering on top of that another container that I'm actually I'm using all the .NET SDK tools because this this is Buster Slim, and this one actually has the SDK tools on it.
Okay.
So it's actually so I'm layering that on so I can actually run these .NET commands. So really, when you look at this Docker file, it's just a series of commands. So I tell it, the starting point, what I want to do on that image. In this case, I'm layering in a second image, and you see the work directory is source. This is actually where my source code gets copied to. And now I'm running the same commands you would run if this were on your own machine to actually build this. And then I run another command to publish it, and I publish it into a, you can see this is actually the base image. I'm renaming this base. So basically what this is doing is I'm creating some intermediary containers along the way. So I pull down the base image, I pull down the SDK image, I build my app in the SDK image, and I publish it to my base image.
Okay.
So I'm using two containers to be able to do all my work here.
And this is going to create multiple containers, or this will create one?
This will create, well, ultimately it's actually pulling down two on my machine, the slim one and then the STK one, but the actual container that's running is this, that I'll publish is really this guy, this the smaller of the two.
So he's going to talk to the other containers that get automatically created because they contain some support stuff.
Yeah, so this is actually a much smaller container to publish than the one with the SDK. So what I'm doing is I'm using the second container to actually build my app, and I'm using that container to actually publish to my first container.
Okay.
So it's kind of intermixing two different containers to help me here. But one really cool thing, so one of the options I have for debugging is actually Docker. So I have Docker running on my machine. In the way that you can see what it's doing, actually this is still running, so that from an earlier test. So Docker PS, I'm just running, getting a list of all the containers that are running on my machine locally, not in the cloud, but on my machine. And I can see that it's actually redirecting traffic from port 44340, which is different than IIS Express was using. So now I can tell that it actually is behaving differently in directing it to port 80 within my Docker container.
Yeah.
The really cool thing about this and where the power comes into play. So when you oftentimes the challenging thing for a developer comes into play when you're building an application, works on my machine, doesn't work on your machine, because I've got a bunch of extra libraries and stuff on my machine that makes it work and that you don't have, and we have to go through this ping pong game to figure out what I have that you don't have. So
yeah, really, that solves that.
Yeah, because what you can actually do is debug the application in a container, and the benefit you have is that if I give you this project, when you debug it in a container, it's actually going to use this container right here, which is the same for you as it is for me. So that container has basic stuff to run .NET Core applications, and that's where my application will run.
Okay.
But the really cool thing about it is that if I set a breakpoint in here, which is normally something you would do when you're debugging locally in your machine, well, it's running locally in my machine, but it's running locally in Docker. So I'm going to set a breakpoint, and I'm going to tell it I want to debug in Docker. And it will take a moment here to deploy it, and it actually hit my breakpoint.
Okay.
So it's actually running now, not on port 44339, but 44340, which is now running in my Docker container.
Okay.
So this is it's the same application just running in this isolated sandbox. All right.
Okay.
So now we have a container created. Now this is the part I have not done purposefully because I wanted it all to work, because you saw earlier, we had some issues with the application I deployed that was the same. So we'll go ahead and try seeing how we can take this application to actually move it into Kubernetes. So if I go back to my command prompt here, say Docker image images, and if I look here, there is net core test. So this is the container that I was running, and in fact, actually, let me just double check and see if that was really the one that was running. It's actually running the development version of it. So I have two versions of this container deployed, and when I hit debug, it was actually running a version of my container. So I have two copies of this thing on my machine. One that's tagged as latest, and one that's tagged as dev. So what I'm going to do, we'll take the exact one that I just made, and we'll tag it just like we did earlier. So this is actually the name of it on my machine, and then I'm gonna grab this. This is the name of what I want it to be in my container registry, and we'll just call it net core test just for sake of argument. And then what I want to do is actually upload this to the container registry. Docker
Okay.
push. This will take a little bit longer because it's not there yet. So this is actually what's happening. So containers are built on top of layers. There's kind of a base one. So we used a base one when we built our .NET Core container, and we had other containers that are kind of part of that. So that's actually what it's doing. It's literally pushing in all these layers, which one of the benefits to consumers of this or users of this is that if only the differentials are pushed. So you can see it's taking a little bit of time to actually get this thing uploaded. If I were to deploy this again and make a simple change to my app, it doesn't have to deploy or doesn't have to push all of the stuff up there. It just pushes the last mile or the part of my container that actually changed.
Yeah. Cool.
So now it is up there. Okay, and this is the name of it.
Okay.
So what we're going to do is go back to Visual Studio Code, and I'm going to just rename this, and I'll call it .NET Core. All right, so while this is in my clipboard, I'm going to paste this thing in here, and we'll call it Taste Core.
Okay.
And I'm going to say the name of my app is Taste Core, the name of my container is Test Core, and then my service is also, I'm going to name it the same. Now, one thing now the name does get important down here because because my load balancer, when traffic comes in to port 80 to my load balancer, I actually am telling it to direct traffic to an app called Test Core. So the app name up here. So there is an important connection between those two. The other names are really just arbitrary, and you can make them anything. I just made them all the same for the sake of simplicity. So now I'm going to go back and run the kubectl command. kubectl apply -f and what I call this net core. All right, so just to make it easy so it's graphical so we can actually see what's running, I'm going to go ahead and do this tunnel back to my Kubernetes cluster.
Okay.
So we can actually watch it. And if I go, back off, restarting, what's going on? Oh no, container, pulling image, failed creating container. What is, so it immediately terminated. Something is going on.
It's because we're recording this.
It said it was a little dicey to try to do something completely off the cuff, but let's see if I go back to services.
Is it still deploying? I noticed that the icon is different.
Yeah, it is still. It's creating the public IP address, so we'll give it. That's usually not a good sign though when it's
okay.
When it fails. But we'll see if we get lucky. Oh, hey, there we go. Maybe I just need. Maybe I was being too. See if we get lucky. Come on.
Still says loading.
Yep. Let me see if I did anything wrong here. Let me just double check here. What did I push it as? .NET Core test. So I didn't actually give it a label. I just, I could have actually said it was dev. I was thinking maybe that was my problem. So we did something not quite right.
Okay.
Let's see if we can ascertain really quickly.
Can we turn it off and back on again?
Yeah, I think I test started container. So it looks like the container immediately is stopping for some reason. I don't. because it started the container and then it basically crashed. So something is able to run locally, not able to run. So let me show you. Let's take a look at something here really quick. If I go back to Visual Studio, and if I run this in Docker.
Not because we set a debug breakpoint or anything, right?
No, that should be, yeah, because that was only on my machine that it had the debug breakpoint. Okay. So Docker PS. So the container has an ID of that. So what I can actually do is I can actually attach to that.
Okay.
And I can see like a standard output. So this is like, standard out. So now I'm actually I'm inside that container just running in Docker, so I can actually see all the debug output. So it's running. I mean, clearly it works.
Yeah, because you're in it.
Yeah. So something's not quite right for it to function in Azure. I guess I should have tried doing that here, but all intents and purposes,
the container works. It's just not working in
exactly.
Azure.
Yeah. There's something amiss inside the container itself. That when the container starts in Azure, so I can see that it actually pulled it down, successfully pulled it down, created the container, and then it started the container, and immediately you can see that this timestamp is the same. It crashed. So let's see. Oh, you know what? I killed my tunnel. So let me just see if there's any logs that we might be able to get lucky and see as one last ditch effort.
Okay.
But outside of this particular issue that we're running into, that should be all that you need to do to actually take an application and actually deploy it.
Looks like the selected container has not logged any messages yet.
Yeah, I see that.
All right. Well, no worries.
Yeah. So something didn't quite go right, but something might be some compatibility problem or something that's actually being requested that I need permission for, or something that might be failing in Kubernetes. So
no, this is actually cool. All right, so here's what we're gonna do, guys. We're gonna go ahead and end this recording session. And Ryan, when you figure it out, give me a quick call, and we'll air the solution. We'll add the solution to the end of the episode.
Yes, that sounds like a plan.
Okay.
All right, but anyway, hopefully that'll kind of give you a good idea of kind of how things are constructed. How you can deploy stuff easily, how you can deploy stuff in a programmatic way, and then how you can build something from scratch.
Yeah. So guys, that's almost your taste of Premier. But we're gonna have a follow-up on this in just a few minutes. In fact, it'll be seconds for you, but it'll be a little while for us. And we'll tell you what the resolution was to this.
All right. Sounds like a plan.
And as promised, we're back. Hey, Ryan, how's it going, man?
It's going good. Yeah, troubleshooting live on the air is always fun.
Yeah, well, this is going to just be a couple of seconds for the viewers, but for us, it was a few hours. Although the fix turned out to be pretty simple.
That's right. Yep.
All right. So, what'd you find?
Yep. So let me go ahead and share, and as this comes up.
Yeah.
So if you recall, there's actually two versions of my application.
Yeah.
And normally when you deploy a container, you can stamp it with a particular version, such as the ones I downloaded, 3.0 Buster. And these are just these can literally be anything. This is just a convention for you to be able to know what version of a container is deployed.
Yeah.
Usually it's a numeric.
And you define those tags, right?
Yeah, exactly. Yeah.
Yeah.
The colon latest is kind of a universally accepted way to literally mean the latest. And in fact, if you don't provide a version when you deploy a container in Docker, Kubernetes, or whatever, it will default to the one that's tagged colon latest. So latest has kind of a particular meaning in the container world, but but you can also, so it's implied because when I deployed this, you see it stamped it with latest.
Okay, great.
So when I was running through Visual Studio, it actually deploys this other one that has a tag of dev, and apparently there's some things that it contains that allows it to be able to interact with Visual Studio, because remember I had breakpoints that were being hit and all that sort of good stuff. So literally, the only thing I did is, let me get back up to where I actually had the fix. Just a second, I passed it. Right here. So my container that I have deployed in my container registry, I did not give it a tag. I just simply called it netcore latest, which means it's going to have that inherent, :latest tag associated with it. So when I did this with you earlier, I was actually tagging the one locally on my machine called dev. So all I did was tag this one to the one I want to actually get pushed up into Azure, and then I just do a Docker push and repush this, which is going to happen really quick because it's already all updated and up to date. That is literally all I did. So
we just had the tags wrong?
That's correct. I deployed the development one. I didn't. It's a fairly newish feature of Visual Studio, and it's actually pretty cool how the breakpoints work and all. So I just assumed that the one with the dev was actually the most latest one on my machine, which it was. But apparently, there's just some hooks and things to make it work with Visual Studio. So literally doing that, and if you recall, my container was in continuous reboot mode, where it would just keep going over and over again, and restart. So by virtue of that, just simply updating my image allowed Kubernetes to say, hey, there's a newer version of my container image, and it sucked it down and went on its merry way. So I didn't have to change anything here. So everything that I'd done off the cuff with my YAML file and deploying it and so forth worked. And if I go into a taste core, I actually updated this to scale for much like we had for our other the other one. So there's actually 2 copies of it. You see everything's all nice and green. And if I go to services, I didn't actually memorize the public IP address, and lo and behold, there it is. But now it's hitting the public IP address that Kubernetes gave it. So that was literally the only thing I changed, is just pushing this new that new container. Right there.
Cool. I did see like some CPU warning.
Yeah. So I had when I deployed this, I didn't actually tell. If you recall in my container file, I didn't actually tell it how much CPU my container, remember I said it was like a minimalist file or deployment file.
Yeah.
So it didn't actually have a CPU number specified, and I think, let me just double check it. I actually believe I have a good example of this. If I go and open up this guy, and just to show you what that looks like, because I wanted to make it simple. This is a much more complex deployment. And this one, rolling updates. This one actually doesn't have a CPU. Oh, there it is. There it is, right there. Yep, I was missing it. Figured it did. So so I'm saying it's 500. This is like a millisecond. Yep, exactly. Yep.
Yeah. Okay. Cool.
So because I didn't have that specified, it's telling me that I should, because I set up a scaling rule, and basically Kubernetes doesn't know what I really need. So.
Yep. All right. Well, cool, man. Thanks for figuring that out for us and making the podcast whole. I appreciate it.
No problem. No problem. Thanks for having me on.
Anytime, dude. All right, guys. This is officially the end of your taste of Premiere, at least this episode. See you later. Bye, guys.